Greetings to all. I, Arpita Kanoja, along with my teammates Anik Datta and Ashutosh Luthra, are here to give brief overview about a project which is on brain tumor detection using a hybrid model. We have made this project under the supervision of Mr. Sanjeev Kumar. Now, talking about why we chose this subject as a major project. Brain is the most significant part that has the most complex structures in the human body. The brain disease is not the same as any part of the body, but it can be caused by the anomalous growth of cells that ultimately destroy the brain structure and cause brain cancer. According to WHO report, it is estimated that 9.6 million people were diagnosed with cancer in 2018. Due to the dire situation and abnormal growth of the tumor and the complexity of brain structure, timely diagnosis is really necessary. The brain tumor can be distinguished into 4 levels, that is from grade 1 to grade 4. Grade 1 and grade 2 are known as low-grade tumors, which is also called as the benign tumor, and third and fourth category is known as the malignant tumor. Once a brain tumor is clinically suspected, radiological examination and continuous monitoring are required to determine its location, size, and the impact it has on the surrounding areas. Now, talking about the literature survey which we did, detection of brain tumor is considered as an image segmentation problem to label whether there is a tumor in the image or not. To answer this problem, different deep learning algorithms as well as image processing methods are implemented by researchers on MRI images. Main issue in image segmentation is to cluster similar feature vectors of an image. According to the recent studies based on image processing, regain-based methods and thresholding approaches are common. Findings of the previous studies are based on different models with their accuracy as rough extreme learning machine, which had an accuracy of 94.23%. Deep CNN had an accuracy of 95%. Deep neural network had, and discrete wavelet auto encoder had a accuracy of 96%, and KNN and CNN had their accuracies of 96.6% and 97.5% respectively. System is trained using different deep learning pre-trained networks like AlexNet, GoogleNet, SqueezeNet, etc. to access the system's best accuracy. Now, I'll be passing it to Anik Datta for proposed work.
In our proposed work, we take MRI image as our input. The first step is pre-processing. Pre-processing is a process of preparing the raw data and making it suitable for the machine learning model. It is used to clean and format the data so that we can process it. We clean and format our data by resizing the image and grayscaling them. Then in the next step, we perform feature extraction. It is the process of transforming the raw data into similar numerical features that can be processed and grouped together. Then we perform training and testing in the ratio of 8:2. The next step is segmentation. Segmentation is the process of separating the lesion area, which is the affected part of our brain, from the normal part of the brain. Then we perform classification. Classification is a machine learning technique which is used for categorizing data. We use two classification machine learning techniques, which are CNN and SVM. Next slide. CNN, which stands for Convolutional Neural Network, is a deep learning algorithm which consists of the input layer, hidden layer, and output layer. It is the type of network. In this type of network, the output of one layer is used as the input for the next layer. CNN model is used for image analysis that consists of 4 stages: convolution layer, pooling layer, flattened layer, and fully connected layer. Next is SVM. SVM stands for Support Vector Machine. It is one of the most popular supervised learning algorithm which is used for classification as well as regression problems. SVM classifier used in the last layer of our fully connected layer of CNN to improve the flexibility and effectivity of the data length to turn the kernel. Next is optimization. It is the process where we train the data iteratively that results in maximum and minimum evaluation. We have used Adam Optimizer. This method is really efficient when working with the large data sets. Now passing to Ashutosh, who will explain the code.
Okay, so now moving to the coding part, here we have used TensorFlow, Keras, and NumPy, Pandas, and sklearn. So I will be explaining you how we implemented the model and what are the results that we are getting. So we have imported the Keras, as you know that Keras is used as a interface for the TensorFlow libraries, and we have used the sequential method here, and we have used NumPy for the mathematical of arrays and matrices, and we have used pandas. So for the data manipulation and analysis, we have used matplotlib, so for the graph plotting, and we have used sklearn for which is a free free machine learning software library used in Python. So moving on, we have used the array here. For 0, we used tumour, and 1 shows the normal, that no tumor. So here we have imported the our data in array form. We have stored the data in this path, and for the yes folder, which means the images with the tumor, we have put it there in this array, and we have resized them, pre-processing. We have did pre-processing in them and resize them in 128 cross 128 format, and same with the images without tumor. And now moving on to the we have reshaped here, and for the training and testing, we, as Anik told, that we have used 80% for the training and 20% for testing. So you can see here test size is 0.2, and we have used the sequential here, and we have implemented the image and flattened the for the better accuracy. We have used the Adam optimizer here, and here we have trained the our model using 30 epochs for better accuracy with a batch size of 40. So to decrease the validation loss to the minimum and increase our accuracy, here we have plot the graph. You can see the test and validation, and here we have shown the result for the output. So as you can see, for the no image, the image with no tumor, the accuracy is coming out 98.03%, as we have used CNN and SVM both. In the first 3 layer of we have used CNN, and the last layer we have used SVM here. So, and at the you can see for the yes part, image with the tumor, it's showing 99.9 accuracy. And so to show this in a better way, so we have tried to implement, we have put it HTML and Flask together to show this. So this is the HTML we have did, and how we have used Flask here, and we have uploaded our model in the .h5 format so that we can use. Let me show you. Yeah, so this is the front end, and we will go to any image. Then I will select that image and check the status. So as you can see, if tumor is detected, sometimes the accuracy is not 100%, but yeah, in some images it show. Yeah, so you can see that it shows no tumor. And if we go to the yes part, Okay, so in the yes part, if I open the image, it shows the tumor is detected. So this is how our model works. So handing over it to Arpita.
So, in the proposed method, deep learning based pre-trained CNN and SVM hybrid model is utilized for classification, and then Adam optimizer is used to improve the accuracy of the results further. We have used the hybrid model to increase the accuracy, and we have done it to some extent. So the model which we have shown has an accuracy of 98.5%. Sometimes, due to the human error, brain tumor prediction leads to wrong medical attention. Thus, to help the neurosurgeon and radiologist for accurate results, this model could be brought into the practices. Now, here are some of the papers which we used for references. That's all from our side. Thank you, and please leave your valuable comments.
Thank you, everyone.
Thank you.